Hello everybody. The main idea behind this webcast is to show how to do a fully unattended deployment of a multi-node OpenStack RDO Havana from scratch. I will show you that it's amazingly fast, and most important, it's fully unattended, so while it deploys you can just have a coffee, for example. Why RDO to start with? RDO is a great open source solution to deploy OpenStack on Red Hat, Fedora, and derivatives, for example CentOS and so on. Very easy distributed deployment based on Puppet, great for proof of concepts as it uses production-ready stable code. DevStack in comparison targets mainly developers. Why multi-node? This is how a real production environment looks like. Distributes the roles, so we have a controller running the APIs, database and so on, a network server running mainly neutron components, and we have multiple compute nodes. Only one deployments are simply too trivial. It's mainly suitable for development purposes, but definitely not for a proof of concept or to simulate a real environment. The network setup and the way in which the components are actually distributed deserves a little bit of time. So as you can see, we have three separate roles. We have the controller node, we have the network node, and we have the compute node. In our demo we will have specifically two compute nodes, one with KVM and one with Hyper-V. It's important to know that there are three networks here. So there is one management network, which is the one with which we connect to every single host, for example to execute SSH commands or similar activities. Okay? And this is not seen at all from the guest operating systems, so from the virtual machines running inside of our compute nodes. And then we have a data network, okay? In this case, we will use typically VLANs to connect our machines, but you could use also GRE, for example, if you use a pure OpenVSwitch solutions, or VXLAN and so on. Or you could just use a flat network. So this data network is the one which is used to communicate between the machines, okay? So all the compute nodes will have a network adapter on this network, and the network node. It's important to note that the network node will have three adapters. So one management, okay, one for the data network, and most important, one for the external network. So this way the network node will act as a router as well, in order to let the virtual machines access the external network. The compute nodes will have two network adapters, one for the management and one for the data network. The controller node will have only the management network. It's also important to know that the management network is used for the virtual machine to communicate among each other. For example, to read and write data inside of the queues, Apache Cupid in this case. Deploying a fully working OpenStack environment requires OpenStack and DevOps skills. You will need to be able to troubleshoot your network, your operating systems, and all these tasks that normally you develop over time. So in the moment in which you are installing your first OpenStack, most probably you need something very, very easy. Otherwise, most users and developers approaching OpenStack face a steep learning curve. And this is mostly due to the fact that we don't have easy tools to facilitate at the moment the introduction of new users to OpenStack. Tools like DevStack simplify the deployment process for developers, but setting up a working environment is still a trial and error process. And again, this targets mainly developers, while we need also a solution that will target users which approach OpenStack from a proof of concept perspective or with the idea to put it in a real production environment. OpenStack everywhere. One of the OpenStack results is the democratization of the cloud. No need for expensive hardware, and it requires only open source and free software. The result is that it's possible to deploy a full multi-node OpenStack on a laptop, no need for dedicated servers, perfect for proof of concepts and development. Full simulation of a non-trivial environment, including all the networking potential issues, uses nested virtualization. So basically you have your virtualization environment, for example on your desktop, that will run virtual machines which in turn will contain virtual machines. New challenges. Here's the very first introduction to a new tool that focuses on proof of concepts and development. Fully unattended setup, from the operating system to the full OpenStack configuration. It has a record deployment time for the simple reason that you can just sit down and watch for the tool to complete its tasks. Nested hypervisor support. For the moment, we support KVM or QEMO for the sake of it, and Hyper-V, including the free edition. As we were saying, we are focusing mainly on completely freely available software. More solutions are going to be added, for example, Xen Server, XCP, or ESXi. The main idea is to focus on environments with limited hardware requirements. For example, laptops, desktops, the tools that you already have in your office or at home. It requires a little bit of RAM, 8 or 16 gigabytes, and at least 50 or 100 gigabytes of disk space. I strongly recommend to use an SSD. They're very cheap nowadays, so most laptops can be upgraded to an SSD, including, for example, the one that we're using for the demo today. Supported operating systems: Windows, Linux, and Mac OS X. So this covers almost every possible client-related option. Initial support is for VMware Workstation, Player, which is the free edition for personal use at the moment, and Fusion, which is the version for Mac OS X. It has a driver model, so new drivers can be added anytime, for example supporting Hyper-V, that we plan to do very soon, since Windows 8 and 8.1 include Hyper-V, VirtualBox, ESXi, and so on. VMware is the only solution at the moment to fully support nested virtualization, including VMX and EPT. Those are CPU flags, and EPT is necessary for Hyper-V as a nested hypervisor. VMX is enough for KVM for the sake of it. EPT support is being added to KVM in the Linux kernel, but at the moment it still doesn't work with nested Hyper-V guests. That's the main reason why we decided to start with VMware as a virtualization solution. Here is a screenshot from our free Hyper-V installer. It can be installed via graphical user interface, like the snapshot you just saw, or in a fully unattended mode. The tool that we're presenting will use the unattended option. It's going to be executed from Linux via WinRM. Think about it like something similar like SSH on Linux. You can see the full script about how it works on GitHub. Okay, we're ready for the demo. We're going to use VMware Fusion on OS X to run it. It works also on Windows or Linux. In that case, you will need VMware Workstation or Player. VMware Player is free for non-commercial use. RDO with Havana is what we're going to deploy, including KVM and a Hyper-V node. We're using CentOS 6.4, Hyper-V 2012 R2, which got recently released. It's going to be fully unattended, meaning that there is not going to be any interaction for running specific commands. Okay? I will record the entire session just to show you how it works. You can get more information about this project on our website, www.cloudbase.it, or on GitHub, where we are going to host the project. So github.com/cloudbase/stackomatic. To show you how it works, we're going to run an integration test, which is actually creating the entire environment. So all we have to do is to just start this command. And as you can see, it's starting to create automatically all the machines. Those are clones from templates which have been created in an unattended mode previously. Okay, here we go. As you can see, all the machines are starting. What happens now is that the script is waiting for the machine to have an IP address ready. They are all including the VMware tools, so the host is able to communicate with the guest and getting the IP addresses. Here they come one by one. The Hyper-V virtual machine in particular, it's taking a little bit longer to boot up because it has been sysprepped, so it has to do all the generalization phase, and also during the unattended generalization, which is starting at the beginning, it's also including the configuration of a WinRM service, which means that we will be able, through an unattended script, to configure Hyper-V in the same way in which we will do it with a Linux box, like with SSH. The difference is that Windows uses WinRM instead of SSH. Here we go. In the meantime, as you can see, we have a controller which is already up and running. we have a network node and we have a compute node running libvirt, in this case KVM. Okay, here we go. The script is made in a way, the configuration script, in a way in which in case of errors there is always a resilience, meaning that it will try again until it works. For example, due to the fact that the machine was rebooting, it lost the communication with the VMware service, but as you can see, it tried again after a timeout and everything worked. We are now injecting an SSH public key inside of all the machines, except the Hyper-V one, of course. Now we are configuring all the networks. So you can see all the machines are running behind. And also very important, we are performing also a connectivity test between the machines on the data network. Okay, we are downloading the RDO bits, just standard RPM and UM process. This is happening on top of the controller. Alright, here we go. Packstack started, running again on top of the controller, and we'll configure all the nodes except the Hyper-V one. Okay? And the Hyper-V will be configured afterwards, still in an unattended mode, starting from our script here. This project is entirely made in Python with an additional script, which is the configure RDO script, which is written in Bash. It can be executed on Windows as well, just using for example, the Bash that comes with the package installed with Git. Okay, deploying packstack in this case is going to be the longest step in the script. It's using Puppet behind the scenes, so it's communicating with all the hosts, it's downloading all the bits, installing all the bits, so it takes a while. A while, of course, measured in minutes. Your mileage, of course, can vary depending on your network speed, your hard drive speed, and your general performance of your hardware. We're running this demo on a laptop, so nothing particularly fancy from this perspective, so we are not using any expensive server or stuff like that. Don't confuse this with our production environments, of course, because the main idea of this project is to make sure that people can get familiar with OpenStack. We don't plan to have production environments running on top of desktops, of course. In the meantime, we can take a look at the configuration in Fusion. As you can see, here are all the templates that we're using, and here are the machines which got just created right now. Let's take, for example, the network one. If we take a look at the settings, we will see that it has 3 network adapters. The first one is connected to the local NATed network. The second one is connected on a private network on the Mac, and this is actually our data network. And the third one, which is meant to be the public network, is again shared with the Mac. Let's take a look at the controller. The controller has a single network adapter which is connected to management network. It has 2 gigs of RAM. In comparison, the network server has 1 gig of RAM, Here's the libvirt host, 2 network adapters, so management and data. Memory is 2 gigs also in this case. Hyper-V, exactly like any other compute node, has a management adapter, the first one, and a data network adapter. Memory is 4 gigs. Okay, RDO will still require 10 to 20 minutes to finish. We can take a quick look at our configuration script in the meantime. Here is how we specify the machines. So for example, we define that the first one, which is a controller, it has a controller role, okay, has a management network, this amount of RAM, CPU configuration, and it's using a template which is called Linux template. Here we define the name, so it's CentOS 6.4 for Linux and Hyper-V 2012.2 for Hyper-V. The second machine is the network one. As you can see, the roles are RDO OpenStack role network. If you want to create an all-in-one environment, you just have to create one machine, adding a bit mask of multiple roles. It has 3 networks: management, data, and public. Here we have the definition of the network. So management is NAT, public, NAT again, and data network. It can be, of course, any other network. Then we have the compute node, in this case the KVM compute node, as you can see from the role. 2 networks, management and data, 2 gigs of RAM, hypervisor type, in this case is libvirt, and libvirt type is libvirt type KVM. We have the addition here of a Hyper-V compute node, which specify OpenStack role compute, exactly like for the KVM one, with the difference that hypervisor type is hypervisor Hyper-V. And also template name is Hyper-V template. Okay, simple. Okay, the prescripts are done. Now it's doing NTPD setup, installing MySQL, Cupid, and so on, and applying configurations. RDO uses Cupid, Apache Cupid, and not RabbitMQ like on DevStack. Okay, let's go on. Keystone, Glance, Cinder, all this stuff goes on the controller. The IP addresses are assigned directly by VMware. Each network has separate dynamic ranges which are created directly when you install Fusion, Workstation, or Player. You can of course configure them the way which you want. Okay, this is the only step that we have to do manually in Fusion. The adapters need to go in promiscuous mode, okay, for OpenVSwitch support on the network nodes, and the same applies, of course, for Hyper-V. Okay, we are towards the end. The pause scripts are the last ones to be executed. Okay, packstack is finished. Now we're doing some extra OpenVSwitch configuration. We are rebooting the machines, and we start with configuring Hyper-V. In this case, as you can see, we just applied, we just created an external virtual switch in Hyper-V using WinRM. Now we are downloading our Hyper-V OpenStack compute installer. So as you can see, we don't have any requirement for, let's say, local packages. We're just downloading everything that we need directly from the internet. And afterwards, it's going to be installed in fully unattended mode. It's a Microsoft MSI style installer, so it can be installed either with a graphical user interface or in a fully unattended mode, like we're doing here. Okay, download finished. Now it's starting to install. It's worked. Taking a look also at the configuration script. Look, it's finished in the meantime. And here we go. It's going to open for us new page. We can RDO into it. Here it is. As you can see, it generated also a public SSH key pair. Okay, so we just have to do source. Okay. Our service list, everything is up and running. Neutron agent list. Everything is up and running, as you can see here, smiley faces and up here. On the compute node, as you can see, you have one which is the libvirt one and one which is the Hyper-V one. Here are the host names. On the agents here, you have a Hyper-V agent running on Hyper-V. You have multiple agents running on the network node, and you have also, of course, the one OpenVSwitch agent running on the controller itself and one on the compute nodes. This one on the, it's not necessarily one on the controller, it's just installed by RDO, even if it's not required. One more thing, let's go on Keystone. And now let's take a look at our this is the IP address of our networking node. Here's the dashboard, and we can take the password from here. Here you go. Not bad. The full execution time for the full installation was 2,200 seconds, which equals to 37 minutes. This really depends on how fast your network is in that specific moment. For example, in this case, it required a few minutes to download our installer, that even if it's only 80 megabytes, it took a little bit of time probably to do some network congestion in the meantime. Okay, this is it. From this moment on, you can enjoy your new installation. You can find your machines here. They can be stopped, snapshot, and everything like any other virtual machine. The next step consists, of course, in starting to deploy an image in Glance and starting to work with your virtual machine directly on top of OpenStack. You can, of course, beside using SSH, you can also log in the console. You have the same identical material. For example, if we run a Nova list, you can see we have no machines and no images so we need really to start from that moment on. Thanks for watching this webcast. If you're interested in more resources, please check out our website www.cloudbase.it and our Twitter handle, cloudbase.it. Thanks.